Welcome back to the online class, students. So last class we discussed about metabolites and introduction of carbohydrate. In today's class we are going to discuss some more points regarding carbohydrates and classification of carbohydrates. Okay. So let us see the points regarding the carbohydrates. These carbohydrates are organic compounds and they are made up of carbon, hydrogen and oxygen. Okay, so they are made up of carbon, hydrogen and oxygen. So in carbohydrates, the ratio of hydrogen and oxygen is as that of water. That is 2:1. Okay, so in carbohydrates, the ratio of hydrogen and oxygen is 2:1 as that of the water. And general formula of carbohydrates is, it is CnH2nOn. Okay, so the general formula of carbohydrates is CnH2nOn. So where the value of N ranges from 3 or more than 3. Okay, so the value of N is equals to 3 or more than 3. So these carbohydrates are also called as saccharides. Carbohydrates are also called as what? Saccharides. Why they are called as saccharides? Actually, the term saccharides has been derived from the Greek word called as saccharon. Okay, so it is derived from the Greek word called as saccharon. So the saccharon means sugar. And not only that, so as the carbohydrates are made up of sugar units, they are called as saccharides. Okay, they are called as saccharides because so it is derived from the Greek word saccharon, which means sugar, or even they are made up of sugar units, hence they are called as saccharides. So let us discuss the definition of carbohydrates. So the carbohydrates are defined as polyhydroxy. Okay, so they are defined as polyhydroxy aldehydes or ketones. Okay, so we can define the carbohydrates as polyhydroxy aldehydes or ketones. Okay, that is the definition of carbohydrates. Okay, see one of the examples for carbohydrate is glucose. So the formula of glucose is C6H12O6. Okay, so I am explaining the definition of carbohydrates here. So the structure of glucose is, so it is one of the aldehyde sugar. So C is 6. 1, 2, 3, 4, 5, 6. Okay. So OH, H, OH, 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 H, 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 OH, here H. Okay. So when you see the structure of glucose, so we can come across there are many functional groups like, so OH, hydroxy groups are many. Okay, so many hydroxy groups are found in case of glucose. So hence the name. So polyhydroxy. Okay, and so they may be aldehydes or ketones. Okay, so the formula for aldehyde is CHO. Okay, the formula of aldehyde is CHO, and for ketone is C double bond O. Okay, so the glucose is one of the aldose sugar because it is containing the aldehyde group. So we can define the carbohydrate as polyhydroxy aldehydes, or it may be a ketones. Okay, so if a carbohydrate has aldehyde as a functional group, such carbohydrates will call it as aldose sugars. Okay, so if carbohydrate contains a ketone as a functional group, we will call such carbohydrate as ketose sugar. Okay, is it clear? Okay, so That is regarding the definition of carbohydrates. Okay. So let us discuss with the classification of carbohydrates. Okay. So the classification, it is based on the number of monomers or the number of sugar units. Okay. The classification is based on the number of sugar units. Based on the number of sugar units, I can classify carbohydrates into three major groups. They are monosaccharides, oligosaccharides and polysaccharides. Okay. So there are three major groups. Which are those? Monosaccharide, oligosaccharide, then polysaccharide. Okay. Polysaccharides. So these are the three different groups of carbohydrates based on the number of sugar units. Okay. So first let us discuss with monosaccharides. Okay. So let us discuss with monosaccharides. So the term mono represents single or one. Okay. So the term mono. So we are going to discuss with monosaccharides. So the term mono represents single or one. Okay. So these are the simple sugars or simple carbohydrates made up of only one sugar unit. Okay. So monosaccharides are, these are the simple sugars or simple carbohydrates made up of only one sugar unit. Okay, so the number of sugar unit it is made up of is only one sugar unit. Okay, so these monosaccharides are soluble in water and they are sweet in taste, and these monosaccharides can pass through the membranes very easily. Okay, so monosaccharides are soluble in water. They are water soluble and they are sweet in taste. And they are sweet in taste. The next, these monosaccharides can pass through any membrane very easily. Okay, so they can pass through the membrane. Okay, so they can pass through the membrane easily. And the monosaccharides cannot be hydrolyzed. What is the meaning of hydrolysis? Breakdown. Okay, so the monosaccharides cannot be hydrolyzed because these are the simple form of sugars. Okay, so they cannot be hydrolyzed because these are the simple form of sugars. Okay, next, when you consider the monosaccharides, so they are made up of carbon atoms ranging from 3 to 7. Okay, so the monosaccharides are made up of one sugar units and which is made up of 3 to 7 carbon atoms. Okay, now let us see the classification of monosaccharides. Okay, so what we are going to discuss? We are going to discuss the classification of monosaccharides. So the monosaccharide classification is based on number of carbon atoms. Okay, so based on number of carbon atoms, we can divide based on number of carbon atoms. Based on carbon atoms, we can divide monosaccharides as follows. Okay, so the first one. So in this case, so the classification what we are going to write now. So the term prefix represents the number of carbon atoms and it will end with O-S-E. Okay, so the first monosaccharide is triose. So as I told that, so in the word, the first prefix the prefix represents what? Number of carbon atoms, and it will end with ose, O-S-E. Okay. So here triose I can define it as. So these are the simple sugars made up of how many carbon atoms? Tri means 3. So these are simple sugars made up of 3 carbon atoms. Okay. So what is the example? So example is for triose is glyceraldehyde. Example is glyceraldehyde. Glyceraldehyde is the example for trioses. So this glyceraldehyde you can find it in most of the enzymatic reactions. Okay. The next monosaccharide what we are going to discuss is Tetrose. The term tetra represents 4. Okay, so the prefix tetra represents 4. So these are simple sugars containing how many carbon atoms? 4 carbon atoms. Okay, these are simple sugars containing 4 carbon atoms. Example for tetrose is erythrose. Okay, so example is erythrose. So erythrose can be found in case of blood. Okay. The next monosaccharide is pentose. So the penta means how many? It is 5. Okay. So the next monosaccharide is pentose. Pentose. So where the term penta represents 5. So these are the monosaccharide, are simple sugars made up of 5 carbon atoms. Okay, so 5 carbon atoms are present. So example for pentose is ribose. Okay, so ribose is the example. One more example is deoxyribose. Deoxyribose. Okay, so where we can find the ribose? So ribose is found in case of RNA. Okay, ribose nucleic acid. So deoxyribose it can be found in case of DNA. Deoxyribose nucleic acid. Okay, the next one is hexose. Okay, the next one is hexose. Hexa means the simple sugars made up of 6 carbon atoms. Okay, the simple sugar made up of how many carbon atoms? 6 carbon atoms. So example for hexose, the best example is glucose, galactose, fructose. Okay, so example for hexose are glucose, galactose, fructose. Okay, so these are the example for hexose sugars. So whereas glucose, it is commonly called as grape sugar. Okay, so it is commonly called as what? Grape sugar. Okay, so even it is also called as blood sugar. The common name of glucose is grape sugar, blood sugar. Okay, so why we are supposed to call glucose as the grape sugar? Because in excess we can find the presence of glucose in the grapes. Hence the name grape sugar. And why it is called as a blood sugar? When we consume the food, okay, so the food will be broken into the simple form like glucose. So that glucose will be present in the blood. Through the blood it will be carried to the cell. Later it will be converted into energy. Okay, so hence the glucose is found in the blood. So we are calling the glucose as a blood sugar also. Okay, and even it is also called by one more name. It is called as dextrose. Okay, because it shows the dextrorotatory, it is also called as dextrose. Okay, the next is galactose. So the galactose it is found as a part of milk sugar. Okay, it is found in milk sugar like lactose. Not only that, even you can find the galactose in some of the gummy secretions, or even in case of mucilage, you can find the presence of this galactose. The next is the fructose. So fructose is commonly called as fruit sugar. Okay, fructose is commonly called as fruit sugar. Okay, so because fructose is found in major cases in case of the fruits. Okay, so hence the name fruit sugar except grapes. And it is also called as levulose. So levulose because of levulose rotatory. So it is also called as levulose. Okay, so this is regarding the hexose. The next one is heptose. As we know that, so the number of carbon atoms are ranging from 3 to 7. The next one is heptosis. So heptosis, hepta means 7 carbon atoms. Okay, these are the simple sugar containing 7 carbon atoms. We'll call it as heptosis. Okay, so the example for heptosis is pseudoheptulose. Pseudoheptulose. Where you can find the pseudoheptulose? It is found in case of most of the fruits and vegetables. You can find the presence of pseudoheptulose, which is the 7 carbon containing compound. Okay, so this is regarding the classification of monosaccharides. So these monosaccharides are also called as, they are called as monomers of carbohydrates. Okay, so the monosaccharides are also called as what? Monomers of carbohydrates. Monomers of carbohydrates. The next, so when you see the structure of this monosaccharides, monosaccharides can have open chain structure or ring structures. Okay, so the monosaccharides will have open chain structure and ring structure. So in ring structure, if you consider, there are two forms of ring structure. One is furanose ring. Another one is pyranose ring. Okay, so first one is furanose ring. Another one is pyranose ring. Furanose ring means it is having pentagon-like structure. Okay, like this. Furanose ring will have a pentagon-like structure, that is furanose ring. So pyranose ring will have a hexagonal structure like this. Okay, so pyranose will have a hexagonal like structure. And in case of pyranose, so inside the ring you can find 1 oxygen and 5 carbon atoms. Okay, the next, in case of furanose, you can find in the ring 1 oxygen and 4 carbon atoms. Okay, so that is the ring structure of the monosaccharides. So here we are going to discuss the structure of only the pentoses and hexoses. Okay, so let us discuss with the pentoses. So in pentose, the first example I am going to take is ribose. Okay, so ribose. So the formula of, the general formula of carbohydrates is CnH2nOn. Okay, so general formula of carbohydrates is CnH2nOn. So now I am going to discuss regarding the structure of ribose. Okay, it is one of the pentose sugar. How many carbon atoms there? The number of carbon is 5. So the formula of ribose is C5, 2 into 5 is 10, H10, O5. That is the formula of ribose. So coming to the structure of ribose, it will have an open ring structure, open chain structure and a ring structure. Okay. So first I'll write up with the open chain structure. 5 carbon atoms, 1, 2, 3, 4, 5. Okay. So where it will have functional groups OH, 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 H, 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 H. So this is a structure of open chain structure of the ribose. Okay. So coming to the ring structure of ribose. So here intermolecular bonding occurs between the first and the fourth carbon atom. Okay, so the intermolecular bonding occurs between the first and fourth carbon atom. Hence, you can find the ring structure like this. Okay, so here you can find pentagon-like structure. Like this, you can find pentagon-like structure. So this is the structure of, that is the ring structure of a ribose, where you can find OH, OH, OH and CH2OH. Okay, so this is the ring structure of a ribose. Okay, then what is the difference between ribose and deoxyribose? So the name itself is that deoxyribose, which will be deficient of one oxygen. Okay, so I'll write the structure of deoxyribose here. The ring structure of deoxyribose. It will be like this. In the place of OH and the second carbon atom, this is the carbon atom 1, 2, 3, 4 and 5. Okay. So on the second carbon atom, instead of OH, we'll have only H. In case of where deoxyribose nucleic acid. That is deoxyribose. Okay. So that is why, so the DNA will be more stable because it is deficient of one functional group, that is oxygen is deficient, which provides more stability to the DNA. Hence, it is found as a genetic material in case of higher order organisms, whereas RNA has, that is ribose sugar has less stability because of presence of one extra oxygen there. Okay. Then next coming to the structure of hexose. Okay. So hexa means it is C6. So then what is the formula of glucose? C6H12O6. Okay, the formula of glucose is C6H12O6. So the formula of glucose is C6H12O6. Okay, first I'll write the chain structure, then I will go on with the ring structure. Okay, so the number of carbon atoms are 6. 1, 2, 3, 4, 5, 6. Okay, and it is a aldose sugar. Aldose means it will have a functional group as a CHO, OH, and third carbon atom orientation changes, because of which you will find OH on the another side. Okay, so OH, OH, OH here, H, 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 H. So this is the open chain structure of the glucose. Next, coming to the ring structure. Because why I am writing the ring structure is, so next we are going to discuss about the bond formation. So we are supposed to know the ring structure to understand the bond formation. Okay. So the ring structure is, so as it will have hexagonal structure. Okay. So here the intermolecular bonding occurs between the first and the fifth carbon atom. Okay, because of that we'll get the ring structure. That will be in the form of hexagon-like structure. Where we'll find hexagon-like structure. So this corner represents carbon 1, carbon 2, carbon 3. So on carbon 3 we know that, so OH will be found on the different orientation. So it will come here, OH. Then carbon number 4, OH. This is carbon number 5. Then here you will find the carbon number 6, CH2OH. Okay, so this is the ring structure of the glucose. Okay, so this is regarding the monosaccharides. So as we know that the carbohydrates are divided into three groups based on the monomers, that is mono, oligo and polysaccharides. Next we are going to discuss with the oligosaccharides. Okay, so the next subtopic what we are going to discuss and the classification is oligosaccharide. Oligosaccharides. Okay. So oligosaccharides. So these are carbohydrates which are made up of 2 to 10 sugar units. Okay, so these are the carbohydrates which are made up of how many sugar units? 2 to 10 sugar units are found in case of oligosaccharides. Okay. The next is these oligosaccharides, as they are made up of 2 to 10. So they will be joined with one another by the formation of glycosidic bond. Okay. So the bond found in case of carbohydrates or oligosaccharides is glycosidic bond. So the sugar units are connected with one another by the chemical bond called as which one? Glycosidic bond. Later, the next one is, so as monosaccharides, these are also soluble in water. They are also sweet in taste and they can pass through the membrane. Okay, so they are also what? Soluble in water. They are also sweet in taste and they can pass through the membrane. They can pass through the membrane. Okay. The next is on hydrolysis. When you break any oligosaccharide, okay, so you can find 2 to 10 sugar units will be formed. Okay, so when we break on hydrolysis, oligosaccharides produces 2 to 10 sugar units. Okay, on hydrolysis, so you can find 2 to 10 sugar units are produced from the oligosaccharides. So these oligosaccharides based on monomers are based on the number of monosaccharides. So we can divide them into the following types. Okay. So we can divide oligosaccharides. We can divide them or we can classify them based on number of sugar units. Based on number of sugar units. You should remember monosaccharides were classified based on number of carbon atoms. Whereas oligosaccharides are classified based on number of sugar units. First one is disaccharide. Okay. Disaccharide. Okay. So di means how many sugar units? 2 sugar units means we'll call it as the disaccharide. 3 sugar units, trisaccharide. 4 sugar units, tetrasaccharide. 5 sugar units, pentasaccharide, like that. Okay. So first let us take up the example of disaccharide. So how many sugar units are there? 2 sugar units. Hence they are called as what? Disaccharides. Okay. So it is made up of 2 sugar units. Next is, so these sugar units are connected by glycosidic bond. Okay, glycosidic bond. And so these are also soluble in water. They are also sweet in taste and they are also able to pass through the membrane because they are also one of the oligosaccharide. Okay, but on hydrolysis, disaccharide produces 2 sugar units. As it is made up of only 2 sugar units, when it is broken, it is supposed to produce 2 sugar unit. Okay. On hydrolysis, how many sugar units are formed? 2 sugar units are formed in case of disaccharides. So one of the example for disaccharide, if you consider, it is, I'll take the example of maltose. Okay, so maltose is made up of two monomers. Okay, maltose, as it is an example for disaccharide, it is made up of two monomers. That is 2 units of glucose. Okay, so maltose is formed by one glucose unit is connected to another glucose unit by glycosidic bond, results in the formation of maltose. Okay, maltose is commonly called as malt sugar. Okay, so it is commonly called as what? Malt sugar. You can find this maltose in case of sprouting seeds. You can see the presence of this maltose. Okay, so one more example for disaccharide is sucrose. The second example is sucrose. Sucrose is commonly called as fruit sugar. It is also called as cane sugar. It is also called as table sugar, which we are using it every day. Okay, so sucrose is also called as what? It is also called as fruit sugar. It is also called as cane sugar because cane contains a large amount of sucrose. Nearly 15 to 20% cane will contain sucrose itself. Okay, then it is also called as table sugar, commercially what we are producing. Okay, so those are the different names for sucrose. Preferably where you can find the sucrose, as I told that it is also cane sugar, you can find it in case of cane, and even in case of some other fruits also you can find the presence of sucrose. Okay, so the sucrose is made up of the two monomers. The two monomers are, one is glucose, another one is fructose. Okay, the sucrose is made up of what? 1 unit of glucose and 1 unit of fructose. Okay, so we are calling it as sucrose. Okay, and this sucrose is called as non-reducing sugar. Okay, so it's an important point. It is called as non-reducing sugar. Why it is called as a non-reducing sugar? Because when the bond formation, when the glycosidic bond formation occurs between the glucose and fructose, glucose is the aldose sugar, so it will have a aldehyde group CHO. Fructose is a ketose sugar, it will have a ketone group C double bond O. During bond formation, so aldehyde group and ketose group are lost. So hence they cannot be reduced. That is, they will not be able to reduce Cu2 plus to Cu2 plus to Cu plus. Okay, so they cannot be reduced. So they are called as non-reducing sugar. So the sucrose is called as a non-reducing sugar because it loses its aldose and ketose group during the glycosidic bond formation. Okay, the next one is lactose. Lactose is also disaccharide which is made up of 1 molecule of glucose and 1 molecule of galactose. Okay, lactose is made up of 1 molecule of glucose and 1 molecule of galactose by glycosidic bond, results in the formation of lactose. Lactose is commonly called as milk sugar as it is found in the milk. Okay, so this is regarding the disaccharide. As I told that the disaccharides are oligosaccharides, so they are connected. So the monomers are connected with one another by the glycosidic bond. Let us see that what is the glycosidic bond. Okay, so for glycosidic bond formation, I am taking the example of maltose. Maltose is formed by the 2 units of glucose. Okay, so let me write the ring structure of glucose here. Okay, so ring structure of glucose: carbon 1, carbon 2, carbon 3, 4, 5, 6. Okay, so I am writing this structure in order to explain what? Glycosidic bond formation. Okay, so this is a 1 sugar unit or glucose. Another glucose is here. Okay, so here also it will have 6 carbon. First carbon, second, third, fourth, fifth, and sixth will be here. CH2OH. 1, 2, 3, 4, 5, 6. Okay, here also 1, 2, 3, 4, 5, 6. Okay. Now the bond formation occurs as I told. So glycosidic bond can be defined as it is a chemical bond formed between the carbon atoms of the neighboring monomers. Okay. So here the glycosidic bond is formed. So between the what? Carbon atoms of the neighboring monomers with the release of one molecule of water. Okay, so here during bond formation what happens? One molecule of water is released. That is H from here, OH from here. So it will be one molecule of water will be released and this oxygen will be shared between the two monomers resulting in the formation of what? Glycosidic bond formation. Is it clear? So here OH of the fourth carbon atom and so OH of the first carbon atom interact with one another and there is a release of one molecule of water excuse, and oxygen will be shared between the two carbon atoms. Okay, so the glycosidic bond will be like this. So first, second, third, fourth, fifth, sixth will be here. And so when you consider the OH, so here the H has been removed. So O will be shared between the two glucose molecules resulting in the formation of a disaccharide called as it is maltose. Okay, so maltose will be formed. So with the help of two glucose molecules connected. So with the release of one molecule of water. That is regarding the disaccharide. Let us see some more questions related to the topic. Okay. So lactose is composed of, we have the options as glucose and galactose, fructose and galactose, glucose and fructose, glucose and glucose. We know that. So the lactose is made up of what? It is made up of glucose and galactose. Option A. The next is, which of the following carbohydrate is absent in honey? Okay. So which of the following carbohydrate is absent in honey? The options are A. Glucose, B. Levulose, nothing but what? Fructose, C. Lactose, D. Maltose. So we know that. So lactose is found only in case of milk, not in case of honey. So lactose is the wrong. That is is not found in the honey. Then sucrose is an example of. So sucrose comes under which one? So it is an example of which? Disaccharide. Okay. So options you have disaccharide, poly, mono, both poly and mono. So the answer is it is a disaccharide. Okay. So which is the non-reducing sugar? Glucose, galactose, mannose, sucrose. We know that the non-reducing sugar is sucrose because during bond formation it loses its aldehyde and ketose group. Okay. So this is regarding the question. Thank you, students.